Hello friends and welcome to your channel GATEquestionsECE. So I am back with next question in the series of random variable and the question code is 120. Consider three independent random variables x1, x2, x3 such that x1 is uniformly distributed over range -2 to 4, x2 is uniformly distributed over interval -1 to 2 and x3 is uniformly distributed over 1 to 3. If z is equal to maximum among x1, x2, x3, then find the expectation of z. In this question, it is not given whether the random variables are discrete or continuous. So whenever it is not mentioned in question, always consider the random variables to be continuous type random variables. So these are continuous type random variables and we will have to find the expectation of z. To find the expectation of z, firstly we will have to calculate the PDF of z. So this is already given in the question and here I have plotted the PDFs of x1, x2, x3. As you can see, x1 is uniformly distributed from -2 to 4. So this diagram is the PDF of x1. So this is the PDF of x1. And this height will be 1 by 6. So this height is 1 by 6. x2 is uniformly distributed over -1 to 2. So this diagram is of PDF of x2. So this is the PDF of x2. And this height is 1 by 3. Similarly, x3 is distributed over 1 to 3. So this diagram belongs to the PDF of x3. So this is for the PDF of x3. And this height here is 1 by this width, which is 2. So its height is 1 by 2. So if we integrate these PDFs, we will get the CDF of x1 and CDF of x2 and CDF of x3. So I have plotted here the CDFs of x1, x2 and x3. This red curve denotes the PDF of x1. This blue line indicates the PDF of x2 and this green line indicates the PDF of x3. Also, let's write down the mathematical expressions for the PDF and CDF of x1, x2 and x3. So the PDF of x1 for a sample value small z, we can write will be equal to 1 by 6 when sample value z is greater than -2 and less than 4 and 0 otherwise. Similarly, the PDF of x2 we can write it will be 1 by 3 for the range of z -1 to 2 and 0 otherwise. Similarly, the PDF of x3 for sample value small z will be equal to 1 by 2 for z in the range 1 to 3 and 0 otherwise. So integrating these, we will get the CDF of x1, which will be equal to, it will be z -2, which will give us +2 divided by 6 in the range when z is greater than equal to -2 and less than equal to 4. And it will be 1 for z greater than equal to 4 and 0 otherwise. So you can see in the above diagram, this red curve represents the CDF of x1. Similarly, the CDF of x2 we can write for sample value small z will be equal to z minus -1, which will give us +1 divided by 3 in the range when z is lying in minus 1 to 2. It will be 1 for z greater than equal to 2 and 0 otherwise. For all other values of z, it will be 0. Similarly, the CDF of x3 will be, so it will be equal to z minus 1 divided by 2 in the range when z is greater than equal to 1, less than equal to 3. It will be 1 for z greater than equal to 3 and it will be 0 otherwise. So these are the expressions for the PDF and CDF in our given question. So now we will find out the CDF expression for z, where z is maximum among x1, x2 and x3. Now from the discussions of previous questions, we know that if z is equal to maximum among random variables x1, x2 and x3, where all of these random variables are independent, then the CDF of z is, for sample value small z, it will be equal to product of marginal CDFs of each random variable for same sample value small z. So f of x2 for sample value small z, f of x3 for sample value small z. So to obtain the CDF of z, we will have to multiply these three CDFs. Now you can observe here that the CDF of x3, this green curve, it is 0 below this value z is equal to 1. So this CDF is 0 below z is equal to 1. So 0 multiplied by anything that is non-zero is again 0. So we can say that the CDF of z for sample value small z will be equal to, so it will be 0 for value of z less than equal to 1. And similarly you can observe that for the value of z greater than equal to 4, all these CDFs are 1. So product of these three CDFs will be again 1. So it will be 1 for z greater than equal to 4. So in between these values from 1 to 4, let's see what are the CDFs. So let's break this whole range from 1 to 4 into small sections. You can observe here that in the range 3 to 4, the CDF of x3 and x2 are both 1. So product of these two CDFs will be 1. So 1 multiplied by the CDF of x1 will be equal to the CDF of x1. So CDF of z will be equal to CDF of x1 in the range z greater than equal to 3, less than equal to 4. Similarly, you can observe in the interval 2 to 3, the CDF of x2 is 1. So if the CDF of x2 is 1, then CDF of z will be equal to product of CDF of x1 and x3. So in the range z greater than equal to 2, less than equal to 3, it will be equal to product of CDF of x1, z and x3. And in the range z greater than equal to 1, less than equal to 2, you can observe none of these PDFs are either 0 or 1. So we will have to take product of all the three expressions for the CDF of x1, x2 and x3. So it will be equal to the CDF of x1 sample value small z times the CDF of x2 sample value small z times the CDF of x3 sample value small z. Actually, why we are obtaining these product expressions is because you can observe in the range 3 to 4, only the PDF of x1 is non-zero. all other PDFs are 0. So we will only get the CDF of x1 in this expression of CDF of z. Similarly, in the range 2 to 3, you can observe that the PDF of x2 is 0. Only non-zero PDFs in this range are the PDF of x1 and the PDF of x3. So correspondingly, we will get the product of the CDF of x1 and x3. And similarly, in the range 1 to 3, you can see all the three PDFs are non-zero. That is, they are overlapping. So because of this reason, we will have to take the product of these three CDFs. So now putting the expressions for the CDFs from these three expressions for the CDF according to their range, we will get the CDF of z will be equal to, so it will be 0 for z less than equal to 1. And in the range 1 to 2, the CDF of x1 will be having this expression. Similarly, CDF of x2 will be having this expression and CDF of x3 will be having this expression. The CDF of z will be z plus 2 times z plus 1 times z minus 1 divided by 36. So that is the expression for the CDF in the range 1 to 2. So next range is z is greater than equal to 2, less than equal to 3. So in this range, we will have to take product of x1 and x3. So this expression and this last expression. So that will give us z plus 2 times z minus 1 divided by 6 into 2, so 12. So next range is when z is greater than equal to 3 and less than equal to 4. So in this range, only the expression of x1. So that expression is this expression. So that will give us z plus 2 divided by 6. And it will be 1 for z greater than equal to 4. So this is the expression for the CDF of z. So differentiation of this will give us the PDF of z for sample value small z. It will be equal to, so it will be 0 for z less than equal to 1. To calculate its differentiation, let's write it over here. So it will be z plus 2 times z square minus 1 by 36. So that will give us z cube minus z plus 2z square minus 2 by 36. So its differentiation will be 3z square plus 4z minus 1 by 36. So that is the PDF in the range 1 to 2. So the differentiation of this term will be z plus 2 plus z minus 1 by 12. So this will give us 2z plus 1 by 12. So this is the expression for the PDF in the range 2 to 3. So next in the range when z is lying in 3 to 4, the differentiation of this will be 1 by 6. So it is 1 by 6 when z is greater than equal to 3, less than equal to, and differentiation of this will be 0. So it will be again 0 for z greater than equal to 4. So this is the expression for the PDF of z. So let's try to plot it. So I have rewritten here the PDF expression for Z, and these are the marginal PDFs of x1, x2 and x3. So now let's try to plot here the PDF of Z. You can observe here that for Z less than equal to 1, the PDF is 0. And similarly, for Z greater than equal to 4, it is 0. So for Z less than equal to 1, this red line here and this red line here for Z greater than equal to 4 represents the PDF for these ranges of Z. So next, for Z greater than equal to 1 and less than equal to 2, you can observe PDF of Z is having a degree of 2. So it is a parabola. So for Z is equal to 1, you can calculate this value will be 3 plus 4 minus 1. So 6 by 36. So it will start from this point here and will end at when Z is equal to 2. So putting here Z is equal to 2, we will get 12 plus 8 minus 1. So it will be 19 by 36. So around here, this is the end point of the parabola. So joining these 2 points, we can draw the curve for parabola will be like this. So this is the graph of PDF in the range 1 to 2. In the next range, when Z is between 2 to 3, it is a straight line. For Z is equal to 2, it will be 5 by 12. And 5 by 12 is 15 by 36. The straight line will start from here, this point, and will rise and will go up to the point when Z is equal to 3. So when Z is equal to 3, it is 7 by 12, which is 21 by 36. So it will rise up to this point. So it will be a straight line joining these 2 points. So this is the graph for the PDF in the range 2 to 3. Similarly, in the range when Z lies between 3 to 4, the PDF of Z is constant and its value is 1 by 6. So 1 by 6 we can write as 6 by 36. So in this range 3 to 4, it will be having this value 6 by 36. So joining these two, it will be constant. So now we can connect the ends. From this PDF of Z, we can make some observations. You can observe here that when there are 3 overlapping uniform PDFs, this is the one PDF, this is second PDF, and this is third PDF, and they are overlapping in 1 to 2 regions. Then the graph for the Z will be a parabola. Similarly, when there are 2 overlapping PDFs, the graph will be a straight line. And when there is only one PDF, then the PDF of Z will be equal to that PDF itself. So these are the results that you can make for Z is equal to maximum among x1, x2 and x3. And moreover, you can calculate that the PDF of Z will be non-zero over the range whose lower value, this lower value will be equal to the maximum among the lower values of x1, x2 and x3. You can observe here that the lower values of x1 is -2, x2 is -1 and x3 is +1. So maximum among these lower values is the value 1. So this is the lower limit of Z over which the PDF will be non-zero. Similarly, you can calculate the upper limit of Z over which the PDF will be non-zero will be maximum among the upper limits of each of these random variables. Here the upper limits are 2, 3 and 4 and maximum among these is 4. So PDF of Z will be non-zero over the range 1 to 4 and outside this range the PDF is 0. So these are some conclusions that you can memorize for Z is equal to maximum among the random variables which are independent. So let's now calculate the expectation of Z that is asked in this question. So expectation of Z will be integration from -infinity to +infinity Z times PDF of Z dz. So that will be equal to integration from limit 1 to 2. So z times the PDF in this range is 3 z square plus 4z minus 1 divided by 36 and dz plus integration from 2 to 3 z times PDF in this range is 2z plus 1 divided by 12 dz plus integration from 3 to 4 z times 1 by 6 dz. So you can calculate this integration and its value will be equal to 1027 by 432. So this is the answer to the question that is asked. I hope you have learned how to solve such questions. So if you have learned anything new from this video solution, then please do press that like button below this video and subscribe to my channel for more such video solutions in future also.